Oh, brilliant. It's a lot of Lego in the background. Sorry. Great. Okay. So thanks, Helen. Hopefully everyone can hear me. I'm going to guess they can. Yes, I'm sure they can. Okay, so yeah, so we decided to put on, or Helen decided to put on, as well as all the fantastic work that she's been doing, a bit of a session on how nature can be used to combat, to help solve the climate change issue. And what we're meaning by that is, and it's growing in interest, and it's growing in the amount of research that's being done on it, but using natural habitats, so grasslands, wetlands, obviously, forests, coastal systems, using the natural ecosystems to help combat climate change. Most of that is going to be the soaking up and storing, so capture and storing or sequestration of carbon, CO2, because we don't want lots of CO2, greenhouse gas in the atmosphere. So a lot of the natural solutions around climate change involve using an ecosystem, different ecosystems, in some way to soak up and then store carbon. And there's two ways that kind of the components of this. You've got there's two ways you can do it. First of all, you've got to look after whatever ecosystem that you're talking about, whether it's a forest, whether it's a wetland, whether it's a mangrove, whether it's grassland, whatever it is, you have to look after it. But the second thing that you can do, and the second thing that's kind of interest to a lot of people that are involved in this area of study, is you have to do something to improve or to increase that ecosystem, that habitat, that environment in such a way that it can store carbon. And the benefits of doing this, well, it's kind of twofold as well. You've got the instant benefit of your capturing and storing that CO2, that carbon in some way. Usually, obviously, it's by plants taking in the CO2 through photosynthesis, using them for building themselves and creating more of them, and then storing it in the carbon, in the sugars, and the plant walls, the plant cells, all that kind of stuff that plants need to do, storing it for a given amount of time. That's what we're talking about. But the second kind of benefit of using a natural habitat, a natural ecosystem to do this is, well, really, there's almost kind of too many benefits to mention. Because if you start to look after your habitats for storing carbon, you have to make sure that whatever ecosystem you're looking at, you have a healthy ecosystem. And by having, just checking you can hear me. Yeah. So by having a healthy ecosystem, you're going to be increasing biodiversity. You may be doing things like preventing flooding or helping prevent flooding. You're going to be doing things like cleaning water as well. So the benefits of doing this, of using natural systems to help fight climate change, are huge. Why do we need to do this, though? Couldn't we just stop burning fossil fuels? If we just stop burning fossil fuels, as we're getting better at, if we stop doing that, would there be any need to do this? If we just stopped, CO2 would be less CO2 would be being released into the atmosphere, greenhouse effect would kind of lessen, and we start to then kind of see the benefits. And we wouldn't get over that 2 degrees increase in the temperature, which so many scientists are saying is what we have to prevent happening. Well, actually, the evidence suggests that's not the case. Even if we just stop right now using all fossil fuel, burning all that kind of stuff that was producing all those greenhouse gases, we would still be increasing our global temperature to those kind of dangerous levels. So we have to do something to soak up that excess CO2. This is a kind of a method called geoengineering, actually. And geoengineering is a way of engineering and manipulating the climate to how we want it to be. And it's very controversial in many ways. And it's not new. Often when people start talking about geoengineering, and if you kind of look at it online or Google it, and you look at kind of some of the media reports of it, you often see these kind of space ship type devices being used, and things like blasting little mirrors into space, all sorts of kind of really high tech gadgets being used to try to control the climate in some way. But actually, geoengineering, adjusting the climate and also the weather, is not a new idea. And it's not even, a lot of it's not even novel science. Some people have been working and looking at this for well over 100 years. A chap called John Pollard Espy in the mid 1800s over in America was nicknamed the Storm King because he was developing ways to create storms and to create rainfall in America to some success. And to taking it further on, and the Vietnamese War, the Americans started to experiment with ways to increase rainfall and flooding over the Viet Cong supply lines. And in fact, in the mid-1970s, the UN created a treaty making it illegal to weaponize the weather. So we know that we can adjust the weather and to a degree the climate as well. And the science is actually relatively robust in certain areas about this. So we know we can do it. And arguably, we have to start doing it. We have to do something if we want to prevent our temperatures from rising to beyond those dangerous levels. And stopping using fossil fuels is not going to be enough. But some of the kind of ways of geoengineering that have been suggested have many pitfalls, which we won't talk about now, but have many pitfalls. But some of them are using natural solutions, such as what we're talking about today, using forests, using trees, using wetlands. These are biological or biogeoengineering techniques. And this is what we should start to be looking at, and what we are starting to look at too. When we start doing this as well, we have to bear in mind that whatever we do to geoengineer or to change the climate, to soak in carbon dioxide, we can't nowadays just think we are the superior beings that can change everything and we can do whatever we want to do. That is not the case. Climate change is showing us as humans, we have to be adaptable. We have to change our way of thinking to fit in with climate change, because so much of conservation, and I've been involved in projects myself for conservation, is when actually we are trying to literally conserve a habitat. And I'm talking about wetlands here, certain types of peatlands and fenlands, and we're trying to preserve or conserve an area of peatland. But actually what has happened is the climate has changed to such a degree that we can't keep that habitat going. And yeah, that's quite scary, but it's also, it can be to our advantage in certain areas. For example, and I have to demonstrate, this is the only thing I have to demonstrate, so don't get too excited, this is going to be a show and tell. But we have here a fantastic globe of the Earth. And we have a certain type of wetlands called mangroves. And I'm sure you all know mangroves, you've seen them in films, you might have kind of paddled around them when you went on holiday to Florida and places like that. Incredibly, amazingly biodiverse wetlands, coastal wetlands, all along the equator. So around about that on our globe. And what's happening is mangroves are only found on the equator, and they're found in specific sort of areas, relatively kind of protected coastlines. But further north and further south, you don't get mangroves. What you do in the same sort of habitats, you get salt marshes, which is what we have all around the UK. And the reason that we don't have these mangroves spreading all up further north and down south is because they don't like the cold. Mangrove trees, and there's different types of mangrove trees forming this mangrove swamp, but they need warm conditions. If you get more than 4 days of frost, mangrove trees die. So what's happening with the earth warming up is you're actually getting mangroves are starting to expand all of further north and further south. Is that good or is that bad? Well, actually, it's good. It's taking over where those salt marshes used to be. But so you might think, oh no, we're losing salt marshes. That's terrible. It's a lovely habitat, salt marshes, you know, really biodiverse, etc. True. But mangroves are better at storing carbon. So as those mangrove areas are expanding, taking over where those salt marshes were, they're actually storing more carbon. I like to think of it almost as if the earth is trying to heal itself. It kind of knows that there's too much CO2 in the atmosphere out there, so it's trying its best to soak some of that CO2 up in some way, using habitats which are better at it than others. So the salt marshes are being lost, shame, yes, but mangroves are taking over. So it's a benefit for us. And if we're trying to conserve areas, if we're trying to manage areas, we have to be thinking all the time now about looking after habitats which have many benefits. And one of the biggest benefits has to be storing of carbon. So if I was a land manager on the coast of Florida, kind of in the north of Florida, and I had the option of cutting down my mangrove trees as they encroached onto my salt marsh because I wanted to look after my salt marsh, would that be the right thing to do? Would that be the right management practice to do? It's what we do all the time in wetland conservation. All the time, wherever you are, when you're managing kind of areas of wetlands, you're often having to cut down willow and scrub, which is encroaching onto your pristine fen or pristine bog, because that's what we want. We want to preserve that fen and that bog. But if I'm doing it when in Florida on the coast there, would I want to do that? Would I want to be cutting down those mangroves, or would I be wanting to encourage them to expand onto the salt marshes? These are sorts of the difficult decisions, or less not difficult, but these are sorts of decisions we are going to have to start making as conservationists, as environmentalists, land managers, as scientists, thinking about what the climate is allowing, the sort of habitats the climate is allowing to grow. So that's just as a little bit of an aside. We have to start thinking about that. What can we do though, as just individuals, or as community groups or whatever? Is this kind of an abstract thing? Are we just talking about big areas like in Florida, the mangroves over there, or peat restoration over in Canada and things like this? Are they the only people that can be concerned about this? Well, not at all. We have to start thinking about greening and using nature in as many different places as possible, whether it's our cities, our streets, wherever it's possible to grow trees, grow hedgerows. We'll be soaking up carbon, but we'll also be increasing biodiversity and having other benefits as well, not just on a kind of human kind of well-being as well. I personally, and I will make my stand very clearly now, is that I think one of the best ways that we can use nature to help climate change or combat the effects of climate change is to use wetlands. And we're going to have Paul on soon telling me that wetlands aren't as good and forests are better. That's fair enough, but he's wrong. And wetlands are without doubt the best stores of carbon possible. Peatlands, a type of wetland which only cover 3% of the Earth's surface, a tiny fraction, store twice the amount of carbon in all the world's forests. That's how effective they are at storing carbon. How do they do that? Like every other ecosystem, the plants, called mosses on most peatlands, sphagnum mosses, they take in CO2 through photosynthesis, and then just like every other plant, they use it to grow and to kind of photosynthesize, etc., etc. But then when they die, like all plants do, they don't rot away, they don't decompose. What happens to all that carbon that was stored in the plants stays stored in those plants. And peatlands build up over time, over hundreds, thousands of years, huge stores of carbon. Different to a forest. If you have a forest and you have a tree, okay, it takes up loads of CO2, brilliant. But then it's got a lifespan of what, 50, 100 years? At that point, what happens? The tree dies, rots away, or you take the tree away. What do you do with the tree? What happens to all the carbon that's been stored in the tree? That carbon, a lot of that carbon is going to be released. Peatlands are different. They store and they trap that carbon for glacial time periods. And the other great thing about peatlands is they're on areas of the world, usually where there's no real land pressures on them. No one really wants to build on them because they're too wet. Don't really have much kind of agricultural benefit. So they've often been thought of as a bit of wastelands, and everything that we've ever done to try and improve them for agriculture, for grazing or anything like that has always been absolutely terrible. So there are kind of benefits for using peatlands too. That said, certain areas of peatlands around the globe are utterly decimated and destroyed for the horticultural industry. So peat is extracted for using in your garden. Over in kind of Indonesia and kind of more around the equator, peatlands are destroyed as well for growing crops on in a kind of a horrendous kind of slash and burn sort of policy. It's not sustainable at all, and all that peatland is destroyed. When you think about peatland being destroyed, you just have to think everything is about carbon. So huge amounts of carbon are being released when that happens too. So we have to, if we want to use peatlands, if we want to really kind of harness the power of the superheroes of the natural world for fighting climate change, we have to look after our peatlands. Yes, we have to do forests, grow forests, forestry, all that sort of stuff. Yeah, that's fine, that's great. Most important thing is to look after our peatlands. Absolutely crucial. We have to look after them. We have to make sure that we don't extract peat for the horticultural industry. We have to make sure that we don't drain them for agricultural purposes. And we also have to help keep them in a healthy condition. But if you remember kind of what I was saying before, when we kind of have to adapt to climate with some of our habitats, because it's called the climatic envelope. So the climatic envelope, which allows certain habitats to exist in certain places, if they're talking things like the rainfall, the amount of sun that an area gets, that's shifting. And unfortunately, that's shifting away from allowing peatlands to exist in certain parts of the world, especially in the UK. So we have to take that into consideration when we're looking at restoring and managing our peatlands. We have to start thinking about how we can encourage peatlands in perhaps adverse climatic conditions. Could we increase the areas where we're finding peatlands? Yes, we could. We can actually start to encourage areas to become peatlands by increasing the amount of water that those areas have, not through precipitation, but through actually flooding those areas too. And interestingly, one of the best ways to do that is to create dams over certain areas and then wait for the water levels to rise. And then hopefully if that water level will stay at a certain depth for a certain period of time, you'll start to have those bogs, those fens starting to form again. And one of the best ways to make those dams is by using beavers. So if you introduce beavers to certain parts of the country, particularly in Scotland, then what could happen is you could be increasing your areas that peat could form. Peat that's the superhero of your natural world when it comes to carbon storage. So it's amazing the things that we can do to increase peatlands forming. Other things that we can do is physically build wetlands ourselves. And so with the Andy Scargill, who is probably in this chat here, he is, yes, there we go. You do not buy peat-based compost, Andy is saying 100% yes. So one of the things that Andy and myself and lots of other people in Chester are now kind of working on is to create a new wetland in the Chester of the Countess of Chester Country Park, which Andy is chair of, and we're hoping to build a wet meadow in that area. Now, this isn't particularly a peat forming habitat, but over time it will be. Over time, the amount of organic matter, carbon, stored in that area will increase far more than if it was an agricultural land, and even if it was a forest. But don't tell Paul that, because he'll get really upset afterwards. So there's things that we can do all over the place to be increasing our wetland environments, increasing the amounts of areas which are designated wetlands, particularly peatlands. And there's things that we can do as individuals to help our peatlands. As Andy says, stop buying peat-based compost for your soil. Don't do it. Don't buy it at all. There's other things we can do as well, such as getting involved with like the Cheshire Wildlife Trust, or if there's other people from other wildlife trusts as well, getting involved with those, because there's a lot of peatland restoration going on. There's also something called carbon farming, which is becoming increasing in interest and could be involved in new agricultural policies after Brexit or whatever has kind of happened or not happened or whatever is happening there, whereby we start to see changes in some of our most iconic landscapes, such as Snowdonia in the Lake District. These areas are artificial. They're heavily grazed with sheep, and it has created what we now imagine is wilderness in these areas. That's not the case. Those areas would be a mosaic of forests and peatlands if they were left alone. Or less intensive grazing. And it could be something that we start to look at as a society to accept, because it will mean serious changes to some of our most beautiful parts of our countryside and our country. But it could be something that which we have to accept if we want to start thinking seriously about using nature to store carbon. And with that, I think I'll leave it.